Hello friends, welcome to Civil Engineering exam. Today we are going to see the problem related with mechanics of solids in the topic of shear and bending in the beams. So the problem is here timber beam of rectangle section 250 mm deep by 75 mm wide is to be reinforced by steel stirrups 8 mm thick on the both sides. Okay, so then the composite beam is simply supported and its ends of 4 meter apart and carries a load of 8 kilonewton is applied at the midspan. Okay, so then find the maximum bending stress in the steel and timber in the midspan. So the Young's modulus of steel is given, that is 2.1 into 10 power 5 Newton per mm square. Then Young's modulus of timber is 0.1 to 10 power 5 Newton per mm square. Okay, so now we can find out the sigma bs and sigma bt, that is sigma b for the steel reinforcement, so then sigma b for timber. Okay, so now for that, so now we know the moment equation, so that is m by I equal to sigma b divided by y. Okay, so now we can find out the moment, so m equal to wl by 4. Okay, so now we can substitute, here weight is given, that is 8 kilonewton, so 8 into 10 power 3 newton into, that is 4 meter apart, so 4 meter span, so the 4 into 10 power 3, so we can take in as mm, so divided by 4. So solving this, we got the value of 8 into 10 power 6 newton mm. Okay, so this is a moment. So next thing is we can find out the y value. So y is 250, the height is 250 divided by 2 plus 8. Okay, so 8 mm thickness. So now we got the value of 133 mm. So next thing is I for steel, so that is equal to b into d1 cube minus d cube divided by 12. So now we can substitute all the values over here. So now b is 75 into 266 cube minus 250 cube divided by 12. Okay, so solving this, we got the value of 19.97 into 10 power 6 mm power 4. Okay, so next thing is we can find out the IT value. So I for the timber, so this is for steel and this is for timber. Okay, so now timber BD cube divided by 12. Okay, so now B is 75 into D is 250 cube divided by 12. Okay, so now we got the value of 97.65 into 10 power 6 mm power 4. Now we can substitute, so that is m equal to sigma b divided by y into I value we can take in as is, this composite section is plus et divided by es into it. Okay, so now we can substitute all the values over here. So m is 8 into 10 power 6 we found out. So then sigma b divided by y value is 133 we found out into, so the is value is will be 19.97 into 10 power 6 again plus et value is given, that is 0.12 into 10 power 5 divided by, so es is given, this Young's modulus of steel is 2.1 into 10 power 5 into it values we found out 97.65 into 10 power 6. Okay, so solving this, we got the value of sigma b, sigma b for the steel. So now we got the value of 41.758 newton per mm square. So this is the stress for the steel reinforcement. Okay, so next thing is we can find out the for timber, so sigma bt equal to e in et, so that is Young's modulus of timber divided by Young's modulus of steel into sigma bs, so that is bending stress of steel. Okay, so now we can substitute all the values over here. So here 0.12 into 10 power 5 divided by 2.1 into 10 power 5 into sigma bs is 41.758 into 8 Newton per mm square. So solving this, we got the value of 2.386 Newton per mm square. Okay, so this is the bending stress for the timber. Okay, so this is the method we can solve the problem. Again, we'll see next video. Thank you.